and this is the solution for matching on the AtCoder DP contest. So we have n men and n women. There's a compatibility matrix for each man and woman ij, and you need to find the number of ways to make pairs where each man and woman belong to exactly one pair, and each man and woman in each pair must be compatible. So n is up to 21, right? So 21 factorial, which would be brute force, will not fly. That's too much for our time complexity. But 2 to the 21 does fly, right? So 2 to the n will work. And that usually means we use subsets. So let's think about that. And of course you can have like n to the power of like 6 or 5 or something crazy like that. But let's see. Okay, so this is how the problem looks like. And in this case, there's 3 different ways to pair it. So let's look at the solution. The solution uses subsets and DP. So essentially the way that this works is if you have some subset S of some subset S, and you want to say, okay, S contains all of the women who are already matched with a man, okay? And this I over here just means that the first I men are already matched with a woman. So that means basically that the size of the set is equal to I, right? And the way that you would calculate this is basically for all women in S, okay? Basically, you would check if they're compatible with I, right? So if man I and the woman, if they're compatible, then you would add dp of S, let's say minus, right? S without the woman, and I minus 1, right? Basically you're saying take this subset, which is where the woman we are now pairing is not included, right? So she's not taken, and where the first I minus 1 men are paired, we're going to pair that man and the ith woman, right? And to find out the number of possible ways to do this, we just add the number of ways to make this subset with the first I minus 1 men, and we add it to this, right? And we do this for all women which are in S and which are compatible with the last man. So the complexity of this is 2 to the n, which is every single subset, right, which you have to calculate, and n, which is just because you have to loop over every woman to do these checks here. And the easiest way to do this would be using bit masks. So you would iterate over every bit mask, which is just 0 to 2 to the n minus 1, and then you do this calculation. And the simplest way, essentially, is to loop over all bit masks, these bit masks, right? And instead of finding which is the last woman which is paired with man I, as we're doing here, right? We're removing it here. Instead, we would do the opposite. Basically, for each dp of some S of I, essentially what we do is we would we'd go for all women not in S, which are compatible, and they're compatible with man I plus 1. Then we would do dp of S plus that woman who's now being paired and I plus 1, because now we've paired all of the men up to this point, and we would add dp of s of I, right? Because essentially how many ever number of ways there is to make this pairing here, we make one more pairing, right? And we would add that to the number of ways to make this pairing. Okay, and that's essentially how the DP works, and the final DP would just be the set with all women up to n, right? So when all women are paired and all men are paired, that's our final answer. So I hope this helped. Thank you for watching, and I'll see you in the next video. Bye.